Hello everyone, welcome to chemistry class. Here we are with the part number 4 of this chapter number 2, chemical bonding. Up to now we have been discussing in this chapter regarding the covalent bonding. We have already discussed about ionic bond. Today we will be discussing the last part of this chapter and we will be learning about the coordinate bond and its formation. In the last part of the video we will be discussing the exercise questions given at the end of the chapter. Let us begin. What is a coordinate bond? The definition is given here. The bond formed between two atoms by sharing of pair of electrons. If we read this definition, it seems the definition of a covalent bond. Then what is the difference? The difference lies in the second part here, that this pair of electron which is being shared is not equally sharing there. In the covalent bonding, a pair of electrons is being shared. For example, hydrogen bonds with chlorine. For example, so one pair of electron is involved in the sharing. So one electron is given by hydrogen, another one is given by chlorine. So that is how the covalent bonding is done. But in case of the coordinate bonding, the electron pair which is being shared, it is coming entirely from one of the atoms. One of the participating atom is giving both the electrons for bonding. That is why it is also known as dative bonding. This is another name for coordinate bond. These types of bond are represented by an arrow symbol. Wherever you will find this coordinate bond, we can write this we can show this with an arrow in the structure of that particular molecule. The covalent bond, as you already know, it is shown by the small dash, single bond, double bond, and triple bond. But in the case of coordinate bond, we have to make an arrow symbol. Examples now, we will learn about these two now in detail. Example of coordinate bonds are found in the case of hydronium ion and ammonium ion. Let us now quickly move on to the formation of hydronium ion, and after that we will see the formation of ammonium ion. After that, this topic 2.6.1 I am halting for now. After discussing these ions, we will come here and discuss this what are the basic requirements. Let us come to understand now the formation of coordinate bond. We will now understand the formation of H3O plus hydronium ion, how it is formed. So this will involve the water molecule. Water molecule is H2O. It is a polar covalent molecule. Polar bond is there, polar covalent bond is there. So how this water is forming the bonding that we have seen earlier. Let us have a short recap. Oxygen atom is in the center of the water molecule. Oxygen atomic number is 8. If we do the electronic configuration, it will be 2 6. That means outermost 6 electrons are there. So we can draw the Lewis dot structure here. So 2 electrons on the top, 2 on the bottom, and 1 on left and right hand side. Both sides we have drawn 1 electron. So now it is bonding with hydrogen atoms. On two sides I have made hydrogen atom. Each hydrogen atom has 1 electron only. Atomic number of hydrogen is 1. So it is having 1 electron only. Hydrogen needs to have 2 electrons. It is having 1 electron. It needs to get 2 electrons somehow, just so that it can complete the duplet. Similarly, oxygen, it is having 6 electrons in the outermost shell. It needs to complete its octet. It wants 8 electrons. So what it is doing? It is sharing 2 electrons with 2 hydrogen atoms. So as a result, a chemical bond, that is a covalent bond, develops here. One on the left side, one on this right hand side. Between these electrons, these are the shared pair of electrons. So the electrons which are involved in the sharing, they are forming the covalent bond. But you can notice now on the top of this oxygen atom, this electron pair is not used in the covalent bond. It is not forming any bond. Similarly, on the downside here, this electron pair is also not involved in the covalent bonding. These type of electrons, whichever pair of electrons are not involved in the bonding, they are called as lone pair. They are called as lone pair of electrons. So oxygen atom is having 2 lone pairs of electrons. These lone pair of electrons, what they will do, they will actually provide electrons for the coordinate bond. In the definition of coordinate bond, what we have seen, sharing of electron is there, but the electron pair is given by single atom. So here this oxygen atom, which is having this lone pair of electron, these lone pairs will actually be shared with another atom for forming the coordinate bond. Now, water, when we are mixing with any acid, for example HCl is an acid. HCl being an acid, whenever any acid is dissolved in water, what is happening? This acid is having two parts. One is positive part, like this H is actually H plus, and similarly Cl is actually Cl minus. So this is a polar covalent compound. So H plus of this is separated, this is dissociated from there. So the polar part, that is the positive part, generally it is broken down. Whenever acid is dissolved in water, we are getting what? We are getting H plus. Now this H plus is what? Actually it is proton. Normal hydrogen atom is having one electron, but that electron, if it is lost, this electron is lost, then what will be left with that hydrogen atom? No electron is there, only one proton will remain, that is only single proton. That is why hydrogen will become, now that hydrogen will become positive in charge. Now that positively charged hydrogen, now what will happen? This positively charged hydrogen from the acid, it will try to get bonded with this oxygen atom. It will request this oxygen atom to form a bond, and oxygen atom, which is already having this lone pair of electron, it is simply uselessly kept here. So oxygen, what this oxygen will do? It will say, okay, you take my two electrons, this lone pair of electron you take, and we will form a bond. So as a result, what happens? A chemical bond is developed, and because hydrogen is not providing any electron for sharing, this type of sharing of electrons is called as coordinate bonding. So the bond will form, and as a result, what will happen? Oxygen in the center, it is already having two covalent bonds with hydrogen atom. Another H plus ion, not the atom, it is the H plus ion, it wants to get benefit of the lone pair. Two lone pairs are there, only one will be used in this. So one of the lone pairs will be used in this case. So what will happen now? Here now this hydrogen will also get involved in this bonding. Now here we will draw an arrow, because one of these three bonds, one of these is actually a coordinate bond. Now we actually can't predict, by looking at the structure, we just can't predict which hydrogen atom, first, second or third, which one is actually forming the coordinate bond. It can be first one, it can be the second one, or it can be the third one. Any one of these we can draw an arrow, but we are sure that there are two covalent bonds and one coordinate bond. Any of these three, total three are there na? So out of these three bonds, any two you can make covalent bond, and one you will make coordinate bond. Anywhere you can make single arrow, any of the directions. So that will show that it is a coordinate bond. Apart from this, one thing left, that was oxygen with three bonds are there, one coordinate bond. Apart from this, what is remaining? Still one lone pair of electron is left there, it is still not used. After this, what we will do now? We will put one positive sign, because why we are putting? Because one atom, that was H plus atom, has been involved in this now. So because of that positive sign, we are putting positive on the complex as a whole. So that is what is the formation of hydronium. In short, just a short summary, you can look over here. Here it is given in this box in the book, you can read through here in this paragraph. Addition of H plus ion to the lone pair of electron of oxygen gives hydronium ion. So H plus is combined with H2O, and what we are getting is H3O plus, that is hydronium ion is formed. Apart from this, in this concept of hydronium ion formation, you have to remember two terms. In this case of hydronium ion formation, oxygen atom of water molecule is actually providing the electrons. Its lone pair are being provided for the bondage, for the formation of bond. So whichever atom provides the electron pair for the formation of coordinate bond, that is called as the donor atom. It is called as donor. So in this case of the hydronium, which is the donor atom, it is oxygen atom. Oxygen is the donor, and the one which is accepting this is, in our example, it is H plus ion, that is the hydrogen ion. So H plus is accepting that lone pair of electrons, so it is called as the acceptor. One is called as the donor, which provides the electron pair. Another one, which is sharing that donated electron pair, is called as acceptor. The one which donates is indicated with the help of an arrow. In this structure you can see arrow has been made and it is pointing towards H. So pointing towards H means H has accepted, it is the acceptor. So that is the two concepts you have to remember, donor and acceptor. Now we will now move on towards the next kind of coordinate, next example actually of coordinate bond, that is NH4 plus, that is ammonium ion. Let us have a look on that. Now here NH4 plus is formed from ammonia. Ammonia is actually NH3. In the center nitrogen is there and it is bonded on three sides with hydrogen atom. Nitrogen atomic number is 7. It is having 5 valence electrons. 7 is the atomic number. If you do the configuration, it will come to 5. That means 5 electrons are in the valence shell. So we will draw 5 electrons in the valence shell. Let us draw here 1, 2, 3 and 1 electron pair, that is the lone pair actually. Now 3 electrons on 3 sides, these are actually involved in the coordinate bonding. With which atom? That is hydrogen atom. One hydrogen atom shares its electron, another hydrogen atom also shares the electron, third hydrogen atom also shares the electron. So 3 types of bonds, 3 bonds have been formed, 1, 2 and 3. This is how sharing has been done. But one lone pair of electron is left, that is the lone pair of electron. Now here also the same concept we will use. Here also when it is reacted with H plus ion, whenever H plus ion, from where it is coming? From acid. H plus ion comes from an acid, it will request this nitrogen to give some electrons. So nitrogen will share its lone pair of electron with this H plus ion. As a result, what will happen? The coordinate bond will form. The coordinate bond will form, and what will happen now? What we will write here is, we will make a arrow sign there. Arrow symbol will be made. Let us have a look here. Yes, ammonia molecule, it accepts. It combines with the hydrogen ion, that is actually a proton, and this H plus gains, not actually gains, it shares this lone pair with from the nitrogen atom. So here you can see now arrow has been made. Another 3 are covalent bond. First, second, third. These are covalent bond. One is a coordinate bond. Number of bonds you have to remember. 3 covalent bonds are there and 1 coordinate bond is there in case of NH4 plus or ammonium ion, which is the donor atom now, which is providing electrons. The electrons are provided from nitrogen atom. Nitrogen is having the lone pair of electrons because lone pair are provided from nitrogen. So nitrogen is the donor in this case. And what is the acceptor one? This one here now H plus. H plus is accepting this lone pair of electrons. It is the acceptor in this case. And how we will write the formula? That is NH3 was already there. It has been combined with one proton. So as a result, what will form there is NH4 whole positive. That is what is called as ammonium ion. This is how the formation of ammonium ion is there. Here as well as in that earlier one, H3O plus hydronium ion, both the cases lone pair of electrons are involved. Whenever we talk about coordinate bond, it is in regard to the lone pair of electrons which are not involved in the covalent bonding, and these lone pair of electrons are provided for sharing by single atom only. The one which gives the electrons is the donor, another one is called as acceptor, which is accepting that lone pair of electrons. So that is, we have seen 2 different types of ions. These are 2 in your syllabus. Let us have a look on this topic, that is self-ionization of water. Now water itself is a polar compound. It is generally broken down. It dissociates into 2 parts. One is called as H plus and second one is called as H minus. Here it is given, water dissociates into 2 parts. One ion is called H plus, that is a proton. Another one is OH minus. OH minus is called as hydroxyl ion. This hydroxyl ion is now having oxygen atom and oxygen is having lone pair of electrons. So if 2 water molecules are present together, they may self-ionize. And what that self-ionization will lead to? That self-ionization will lead to the formation of H3O plus, that is hydronium ion can be formed in the water itself without the presence of acid also it is possible. So if water molecule dissociates into two parts, then this H plus will again react with water molecule. First of all, what is happening? Water breaks down into two parts. One is H plus and another is OH minus. Now this H plus which has been broken down, it reacts with another water, not that earlier one. That is first water molecule, this is second water molecule. This H plus now reacts with second water molecule, and now what will form? It will form H3O positive. That is what is hydronium ion. So here you see the equations. First it is broken down, water broke down into two parts. Now this proton will now react with water. This is first molecule of water, this is another one. Don't confuse, it is not going again back there, it is not going there. It is this hydrogen positive is reacting now with another water molecule, and it forms this ion here. How this is formed, that we already know. Oxygen is having what? Oxygen is having two lone pair, and when this H plus proceeds to this oxygen atom, one of the lone pair is provided to this for coordinate bond. As a result, coordinate bond formation take place, and you can see this we have represented with the help of an arrow. That is how the self-ionization of water is also possible. And take a note, again and again I am telling, for self-ionization it needs minimum two water molecules to take place. Single water molecule cannot self-ionize. That is all for this formation of coordinate bonds. Let us now quickly come to a topic that we left in the beginning. There was the conditions. Now what we have learned now regarding the coordinate bonding is the conditions we can formulate based on that. So for the coordinate bond, two atoms are there, and one of those two atoms must have a lone pair of electron. You should have understood by now. So if lone pair of electron is not available on one of the atom which are involved in coordinate bond, then this bond cannot take place. So ammonia, for example, nitrogen is having lone pair of electron, and in water oxygen is having lone pair of electron. The definition of lone pair of electrons is given there. You can learn that. That is what? It is the pair of electron which is not shared with any other atom. Not shared, or in other words we can say a pair of electron which is not involved in covalent bonding. That is called as the lone pair of electrons. Next one, the next condition is, second one is given there. Another atom should be short of at least a pair of electron. First condition was there should be lone pair. Second condition is there, another atom which is not having lone pair, it should be positively charged. It should have a positive. That's all for the topic of coordinate bond. Apart from this, one more thing. Yes, here some examples are given and some extra points are there. Here you see ammonia. In this case of ammonium ion, NH4 positive, it combines or it forms an ionic bond with chloride ion, because NH4 positive is actually what? It is having positive charge, and because of this positive charge it is attracted towards negatively charged chloride ion, and this will lead to ionic bond. So in this compound, that is NH4Cl, ammonium chloride, this is a very good example which is having all types of bonding. One is 3 covalent bond are there, one coordinate bond is there, that the arrow is showing there, and it is full complex is positively charged, and it is also bonded towards negatively charged chlorine. So this positive and negative attraction will lead to what? It will lead to the formation of ionic bond. So one coordinate bond, one ionic bond, and 3 are the covalent bonds. This is a perfect example of a single compound having all types of bonding. Apart from this, some more are given. The examples are given: NaOH, CaCO3, calcium carbonate. These are having two types of bonding: electrovalent, ionic, or the second one is covalent bonding. Two types of bonding are there. Here you can see the structure of sulfuric acid, H2SO4. In the center, sulfur is there, and it is forming two coordinate bonds with oxygen atoms. So two coordinate bonds are there, one on this side, top side, one on the down side. This is two coordinate bond, and 4 are the covalent bonds. So it is having covalent as well as coordinate bond. Now move towards the question answer, the exercise part of this chapter, and try to have a review of the answers. Here we are with the exercise part of chapter 2. The questions we'll see now. Question number 1, define a coordinate bond and the conditions. So the definition is the bond between two atoms forming or sharing a pair of electron, and this pair of electron is provided by one of the combining atoms. That is coordinate bond. The conditions two are there. One of the atoms should have lone pair of electron, another should be having an absence of lone pair of electrons. The question 2, what do you understand by lone pair and a shared pair? Lone pair is what? The pair of electron which is not shared with other atom. On the other side, the pair of atom which is shared, is the name itself is telling it is shared pair of electron. Shared pair forms a covalent bond. Lone pair forms a coordinate bond. Next, question number 3, state the type of bonding in these molecules. So first one is water. In water we are having polar covalent bond. Second, calcium oxide. Now calcium is actually positively charged. It forms Ca2 plus and oxygen forms O2 minus. So positive and negative charges attraction will lead to what? It will lead to ionic bond. The next one, C part, is hydroxyl ion. Hydroxyl ion, just now in the class we have seen that is OH negative. It is actually forming what? It will form a single covalent bond in itself. They are not asking OH with anything else. Between oxygen and hydrogen, which kind of bond is formed? That is a single covalent bond. Next is the D part. They are asking methane. Methane is actually CH4 and carbon is bonded on all four sides with hydrogen atom. Carbon in center and on all four corners is hydrogen atom. All are bonded in a covalent bond. Then E part is ammonium ion, that is NH4 plus. It has coordinate bond. F part is ammonium chloride, NH4Cl. Now NH4Cl is having all the types of bond. One is ionic bond, second is coordinate bond, and third is covalent bond. Question number 4, we have to draw electron dot diagrams for these figures that you can draw. Next, we have to state the type of bonding present in them. So the figures are given here. I hope you can draw these yourself as well. Now let us see the B part. Two examples they have asked. In the first part they have asked coordinate bond compounds. So two examples are given there. One is ammonium ion, second is hydronium H3O plus ion. These both are having coordinate bonding. One is ammonium NH4 plus, second one is hydronium H3O positive. Next one, now B part, is they have a solid covalent compound. The question you can see in the book as well. Solid covalent compound. The answer is given phosphorus pentachloride and diamond. Both these are solid covalent compound. Third, they have asked gaseous compounds but polar in nature, means polar covalent bond should be there but the compound should be gaseous. So HCl is having polar covalent bond. And second, water vapor, because water in gaseous form is water vapor, so water is also polar bond, so that is why water vapor. Next, gaseous non-polar compounds, so those type of covalent bonds which are non-polar but gaseous. So oxygen O2 molecule, and next nitrogen gas, that is N2 molecule. The fifth part now, liquid non-polar compound. This is toluene and gasoline. These are non-polar liquids. These are generally used as solvents. Next, question number 5. Element M forms a chloride with the formula MCl2. Now the formula you can see MCl2. Now Cl2, this 2 shows that the valency of M is this 2. So based on that, now you have to tell if valency of M is 2. So M will be in which group? Out of this, magnesium is having valency 2. So M can form a bond with magnesium because both are having valency 2. Next, now question number 6. You have to complete this given table. According to the table, you have to write the answers. So the answers have been mentioned. Sodium and its formula with chloride. So sodium, if it react with chloride ion, Cl minus ion, it will form NaCl. Phosphorus react with this, it will form PCl5, because phosphorus valency you will take note. Next one, carbon having valency 4, so it will form CCl4. Nature of bonding, NaCl is ionic, phosphorus is covalent, and CCl4 is also covalent. In the physical state, you can see here all are given. Question number 7. How many atoms of each kind are present in the molecules? Now this the compounds are given. You have to tell the number of atoms. So by writing the formula itself, the chemical formula itself can show the number of atoms. Now calcium oxide is CaO. Ca means only one calcium atom and one oxygen atom. By the formula itself you can know. Next is chlorine. Chlorine molecule is Cl2. Now you can say 2 chlorine atoms are there. Next one is water. We all know H2O, 2 hydrogen atom and 1 oxygen atom. Next, carbon tetrachloride, that is a covalent bond molecule. So it is CCl4. C means 1 carbon atom, Cl4 means 4 chlorine atoms are there. This is a simple question. B part now. They have asked now here in the same question itself how many electrons are, let me bring the question here, how many electrons are required by each atom to attain noble gas configuration, nearest noble gas configuration. Now in A part, all these atoms we have mentioned. Out of all these atoms we have to tell one by one how many electrons are required for each of them to be like noble gas. Now calcium from Ca2 plus, so by that valency itself we can know it will donate 2 electrons. Next one, oxygen is 2 minus means it is gaining electron, and how many? 2, so that is accepting 2 electrons. Chlorine from Cl minus, that means it accept 1 electron. Next, carbon we already know it forms covalent bond and its valency is 4, so carbon will accept 4 electron by sharing. It will share electrons and it will form covalent bonds. Next, hydrogen is already having 1 electron. It will accept 1 more electron from some other atom, so it will also share 1 electron. That is all for this question. Question number 8 now, fill in the blanks. Fill-ups are given. First one now, when the nuclei of 2 reacting atoms are of dash mass, then a bond so formed is dash covalent bond. So if the 2 reacting atoms are of unequal mass, then you can say it is polar bond. So in the polar bond, the atoms are of unequal mass. B part now, in case of the non-polar covalent compound, the covalent bond is formed in the middle. Non-polar covalent bond, where the bond is forming, it is in the middle, exactly in the middle, and the shared electrons are equally distributed. Second dash will be equally distributed. C part now, ionic compounds do not conduct electricity. Ionic compound conduct electricity in liquid state or in aqueous state. Not liquid is not the right word, aqueous or molten state, but in the solid state they do not do so. So solid is the answer. Next, D part, the ions in the dash compound are held very strongly due to dash force. So ions are where? Ions are present in the electrovalent compound or ionic compound. So first dash will be electrovalent compound. And why the ions are held strongly? Due to electrostatic force of attraction. So second dash will be electrostatic. Ninth question now, compound X consists of molecules and we have to choose the letter corresponding to the correct answer. A, B, C, D options are given, and based on that X compound we have to tell. Now from the first line you have to take a hint there. What they are telling? Compound consists of molecules. And in the properties of covalent and ionic compound, we have seen that ionic compounds are having ions and covalent compounds are having molecules. So if molecules is written, that means compound X is what? It is covalent in nature. So this is how you have to apply your knowledge. So because molecules word is written, so this compound consists of molecules. If ions would have written, then we will say it is ionic compound. Molecules is written, so it is covalent compound. So by that now it is very simple question now. If you have applied that way, it is very simple now. So now type of bonding in X is covalent, and in covalent what type of bonding will be there? Covalent bonding. Next, X is likely to have in covalent bonding, what is the melting and boiling point? Melting point is low, boiling point is also low. Next, now third part, in the liquid state X will, so covalent bond in the liquid state it will be ionic. No, it is not an electrolyte, it is not conducting electricity. The answer is D part, X will not conduct electricity. Remaining 3 are the properties of ionic compound, and the last property is of the covalent compound. Question number 10 now, electrons are getting added to Y. So 2 parts they are asking, is it getting oxidized or reduced, and second, which charge will the Y migrate to? So answer is Y is getting reduced because of gaining of electrons, and because Y is positive, it will go towards the negative electrode. In the B part of this question number 10, they have asked the question I'm reading from here. What acids dissolve in water and produce positively charged ion? Draw the structure of these positive ions. So now what they have asked, is acid dissolve in water and produce positively charged ion. So if acid dissolve in water, in the class of coordinate we have learned acid dissolve in water, what is produced? It is producing H plus ion. H plus ion is produced, that you have to remember. So here again we have to apply our knowledge. Acid dissolve in water and what they are producing is H plus ion, and we have to draw the structure of these positive charged particles. So what will form as a result? This H plus ion will combine with water, and what will form as a result? It will form H3O whole positive ion, that is hydronium ion. So they are not directly asking to draw the structure of hydronium ion. First they are verifying you know this concept or not. So first they are asked acid dissolve in water and produce the positively charged ion. So after acid, this is the part of acid, it is dissolving in water, and which ion is produced. If you know that ion, then only you will draw. So that is how we have to apply our knowledge. So the structure is given here. Then C part now. The question is explain why carbon tetrachloride does not dissolve in water. Now CCl4, this is a covalent compound, carbon tetrachloride. On all four sides chlorine is there. Now carbon and chlorine bond, this carbon and chlorine bond is actually polar. Carbon is actually partially positive and chlorine is actually partially negative. In the class of covalent I missed this topic. See, this carbon is positive, partially positive, chlorine is partially negative. As a result, what is happening? Polarity is coming. So if there is single bond of carbon and chlorine, then what will be there? There will be polarity. Single bond is actually polar in nature. This is a polar bond. So one polar bond is there. On the opposite side of this also again another polar bond is there. So this polarity is balanced by this, or we can say it is cancelled. One side polarity is there, is coming, on the other side also polarity is coming. So the net polarity comes to be 0 because exactly opposite direction both the polarities are forming. As a result, this net polarity will come to be 0. Similarly, on the left side one polar bond is there, and extremely on the opposite side, that is on the right side, another polar bond is there. Here also net polarity will again come to be 0. So what we can say, as a result of this, what is happening, the symmetry of the molecule is present there, a perfect geometrical figure is there. As a result, this single molecule of CCl4 will become non-polar. On the other hand, if single bond is there, then it is polar. So this I missed, so I told here. So the question was here what? There was that why it does not dissolve in water, because CCl4 is non-polar covalent compound. CCl bond is polar, but if it forms bond on all four sides, it becomes non-polar, and non-polar compounds cannot dissolve in polar compound. Let us now come to the question number 11 now. Element Q and S react together to form ionic compound. Under normal condition, which physical state will they exist? So ionic compound, generally they are solids. Next now, can Q and S both be metals? So if it is ionic, in the A part they have told ionic bond is formed, so they cannot be metal. So if ionic compound is there, one element is metal, another one is non-metal. So answer is no. Next, the property which is the characteristic of electrovalent compound is. Now here four options are given. What is the property of electrovalent compound is fourth point, that is it is having high melting point. Next, D part, when a metal atom becomes an ion. So if metal is becoming ion, metal is converting into ion, then it is losing electron and is getting oxidized. Next now question number 12. In the formation of magnesium chloride MgCl2 by combination of magnesium and chloride, name the substance that is oxidized and that is reduced. One is getting oxidized, one is getting reduced. Here the concept of oxidation and reduction they have asked. So magnesium is losing electron. Magnesium converts into Mg2 plus by the loss of electron. It releases 2 electron, and these 2 electron are absorbed or gained by what? These are gained by chlorine, and the chlorine converts into Cl2 minus. So the one which is one side, what is happening? Loss of electron is happening. So this is what is happening is oxidation is happening. The magnesium oxidizes. On the other side, chlorine is accepting. So for the chlorine is actually reduction is happening. It is reducing. So chlorine reduces here. So here the answer is given. Question 12b. What are the terms? You have to tell the term. The definition are given. First is share the pair of electrons, that is covalent bond. Now here shared pair of electron, what is happening? Both the electrons are coming from same atom. So that is coordinate bond. So we have covered a sufficient part of the exercise. I will take a halt here in the video. The remaining questions, these are the previous year questions. You can see in your textbook, page number 36. These previous year questions we will be covering in the next part of the video that will be coming shortly. That's all for this video. Thank you.